Hi, my name is Mark Sholin, founder and CEO of ArbSource. ArbSource is a water technology company where we actually use biotechnology principles to enable fast, efficient, and modular wastewater treatment targeted for the food and beverage industry. So what we do is we utilize a special naturally occurring group of bacteria called anode respiring bacteria. That's ARB for short, hence our name ArbSource. And so these organisms, we grow them inside our specially configured bioreactors that use an anode-cathode type interaction. And what we do is we can break down the sugars, starches, proteins, these type of non-toxic, biodegradable pollutants that are common in food and beverage waste streams. We break down these pollutants through hydrolysis and fermentation and can actually capture the chemical energy from those bonds and utilize them on the back end through electrochemistry to create different types of value-added byproducts, for example, hydrogen or caustic soda, or even electricity directly. Source is actually a technology spin-out from Arizona State University. I'm formerly a PhD student there, and a number of our team comes from there as well, our engineers and folks on our technical advisory board. So, water infrastructure is something that's kind of not necessarily thought about much, among the Main Street populace, but there really is a lot of work that goes in on the back end to ensure that we as a society really have a reliable and safe drinking water supply and have the ability to get rid of our wastewater effectively and safely and to be able to continue that cycle long term. However, there's, as our population grows and as the kind of activities that we do increase the complexity, that basically translates into more challenging water issues that we have to resolve. Water scarcity, pollution of our waterways, so on and so forth. So, being in technology spin-out from the university, there's a lot of great, very cutting-edge research that goes on there. And me as a PhD student, did some work with this technology concept called microbial electrochemical cells, which is what ArbSource is all about. And we, found out in the lab that these ARB are very good at treating a lot of the common types of pollutants that we see in wastewater streams today. As the founder of ArbSource, one might ask themselves, well, what would prompt someone, like me or like Mark to start such a, nuanced technology company? Where do you get an idea like that from? Well, the story actually begins way back in elementary school, in first grade. Interesting anecdote that I like to share from time to time is I recall sitting around, with all first grade classmates, and they have the cliche question come up by teachers and staff or whoever that go, well, what do you want to be when you grow up? Well, answers that you normally hear, oh, I want to be the president, or I want to be an astronaut, whatever, firefighter. But I'd always give the quirky answer of, I want to be a hydrologist. And, well, what's a hydrologist? I didn't really necessarily even know at the time what that was. But what the gist of my answering that question that way is that I knew that I wanted to be involved in water. Being a native of Phoenix, I think we all understand living in a desert environment like this, that water issues are very pressing. And it's something that, I wanted to devote my time towards helping ensure that we can maintain this type of quality of life in a sustainable manner through technology. And I think that kind of attitude I had going in from such an early age is what prompted my interest in chemical engineering. And so I do have come from a chemical engineering background, graduated with a degree in that, and pursued PhD studies at ASU on it as well. And it was the result of this material I was exposed to during my studies there at ASU, which prompted the founding of this company, knowing that the time worked out really well in terms of the technology development pathway and kind of where it's been in the past 10, 15 years or so as a concept, and being right at that cusp, that inflection point of being ready to push out into the real world. And the fact that, it so aligns so well with my long-standing interests in water and, both on the drinking water and wastewater treatment side, it's just a great fit all around. As you can imagine, with such a cutting-edge technology like this, that with still a lot of unknowns involved with how it really works at that micro scale, prototyping and being very deliberate with that process is key to ensure that we aren't spinning our wheels, so to speak. That we're not, putting in effort that won't really bear fruit on the back end because the experimentation or whatever types of processes that we put in just don't end up helping us understand what's going on. So there's a lot of bench scale work involved with doing characterizations on a microbial level of the syntrophic nature of these anode respiring bacteria and how each different strain interacts with each other to enable that treatment, that breakdown of these organic pollutants, and being able to maximize or optimize the kind of return on energy we can get essentially on the back end, on the cathode side of our reactors. So what that entails for us is a lot of testing day to day, where we set up bench scale reactors, running them at different testing conditions, for example, various pHs, temperatures, using different types of wastewaters, both ones that we make synthetically in the lab and others that we source from potential end users. For example, we're working with a number of local Arizona breweries and potato chip processors to be able to do some kind of real testing of their wastewaters, but still under lab conditions. So we do collect a whole slew of data as we run these testing cycles. Is just a few examples. We take readings for COD reduction, which is basically a measure of the organic pollutants in wastewater. And we also take continuous readings of the current that we read in between our anode and cathode, take different readings of voltages that are applied, and then we can also get on the back end as well. Overall, the prototyping phase, it's all about being very, very meticulous in the testing conditions that you set out prior to running these experiments, making sure that there's high quality control, meaning doing everything in duplicate or even triplicate sometimes, and being very cautious about and proactive even in managing whatever kinds of unknowns that you'll encounter during that testing process, because many will crop up. So it's all about taking good notes and using that data to come to as accurate conclusions you can get on the conclusion of your experiments. So as of early 2013, when this is being filmed, ArpSource has been around for a bit over 2 years. The bulk of our funding to date and support from development comes from the Department of Energy. So we utilize resources from from various federal agencies to help push this technology forward and help expedite our path to market. There's also a number of commercial strategic partners that we work with, also to help cut down the cycle times that we have to put in on the front end to get our technology where it needs to be to enable that mass market appeal at scale. What this really involves, at a large scale, of deployment of what we call this ARB cell technology, where we can treat this wastewater on site at food and beverage processing facilities, for example, breweries, dairies, or potato chip companies. We are looking for an on-site treatment approach, meaning that these are modular reactors that we install just like you would any other piece of equipment to enable whatever types of processes that are, these end users use day to day. ArbSource, being a resident client of the Center for Entrepreneurial Innovation here at Gateway, has been a real boon for us. We could not be happier with the support and the space that we've been granted here, is to help incubate us as a company and to help push our business forward, help us get to revenue and beyond. A lot of the work that we do at CEI really is all about product testing and product development, building bigger. And CEI provides us with a lot of really all the resources we need, certainly in terms of infrastructure, in order to help us with that scale-up process. Our vision, though, CEI being an incubator, it's not something that is designed to hold us for the remainder of the existence of ArbSource. And really, next steps are after we do establish our proof of concept at full scale, which is something that we plan to do here at CEI in the 2 or 3 year residency period we anticipate. The next step certainly would be to expand outward, create a more robust, design from ground up manufacturing infrastructure for this technology, and to bring on the right kind of staff of engineers and installation specialists to just really expand our footprint across both the domestic and really international market to enable the next generation of on-site wastewater treatment for the food and beverage industry.
Hi everybody, my name is Greg Bullock. I'm the marketing assistant here at the Center for Entrepreneurial Innovation at Gateway Community College, also known as CEI. And what we do here is basically we help early stage and startup companies grow their business, whether they're in the very early stages of trying to acquire funding or just kind of make a name for themselves, to other companies who are a little bit beyond that and are actually looking to commercialize their business and take it to the market. So we bring clients in and we give them access to all sorts of resources, from student research teams and mentors and business counseling. And it's really just for the purpose of helping to grow these companies to create jobs in the region and in the state. So that's what we do here at CEI.